Hey guys, how's it going? We have been doing few videos covering different aspects of the RTX 5090 AORUS Master. We did first the unboxing, tested coil wine, and the screen cooling fan which comes additionally with this GPU. If you are curious to know about those topics, make sure to check their dedicated videos out. In this video instead, we'll be doing some overclocking to maximize performance by up to 6% while still keeping things super stable. In case you are not aware, the AORUS Master in BIOS performance mode already comes pretty overclocked out of the box at 2655 MHz. Compared to other IAP models and Founder Edition, it's probably set more than all. The reference boosting clock of the RTX 5090 is 2407 MHz, so that's already a 248 MHz factory overclock out of the box. Still, I found that it can handle even more. So we'll not only raise the GPU core clock, but also the memory one, while also testing stability and checking performance. So let's get to it. The process is pretty straightforward. When you get this GPU, you will want to install Gigabyte Control Center, or for short, GCC, to control various settings like fans, RGB, and the LCD screen. It also packs performance tuning. In the performance tab, you will see the GPU boost clock. Just dial it up by plus 150 MHz, and it will show now 2805 MHz as the new boosting target clock. There's also an OC scanner built in if you prefer to let it handle the boost automatically. You can adjust the power limit, although GPU voltage and temperature limits are locked in here. By default, power limit is set at 100%, and while you can't increase it above that, as we already hit the ceiling with 600 watt max power draw, you can still reduce it to lower temps if you would like. As for memory, I applied a maximum of 6000 plus MHz, which is the limit this Samsung memory model can usually handle before the stability issues kick in. Note that GPU-Z shows 2125 MHz for the memory clock, but that's not the actual operating speed. It's just half of the real clock because actually GPU-Z reports the base clock, not the full one. GDDR7 uses an octal data rate, so the real effective speed is 8 times the actual clock. In my case, I set 34,000 MTS in GCC, which means the actual memory clock is 4250 MHz. GPU-Z just divides that by 2, so its reading is technically correct by all the standards, but for GDDR7, it doesn't show the whole picture. So we increased it by 375 MHz powered by 2, so it means 750 MHz. Now the reason I'm not doing this overclock through MSI Afterburner is pretty simple. While Afterburner lets you control GPU core clock pretty much all you want, its memory slider offset is limited to max of 2000 MHz, which is way below than what the memory can actually handle before having any issues. So if you want to squeeze the maximum performance out of your memory, Afterburner doesn't allow it at the moment. However, a great feature Afterburner does have, and one that I wish GCC had, is the curve editor. I like using it because it lets you tweak voltage points per frequency. It's useful for leveling high points to minimize sudden spikes and improve performance consistency. So for example, if you shift select the top points on the curve and press Shift plus Enter, it opens an input box where you can directly enter your desired frequency, and in my case, I've put 3000 MHz. You can enter less if you would like, and once that's done, you can select the opposite end of the curve and apply a small offset to smooth it out. Sometimes certain voltage points have an abrupt jump, so you can manually flatten or smooth those points as needed. That was just a demonstration to show how powerful the curve editor is, and I really wish something like that was built in into Gigabyte software. Now if you are curious to see what kind of curve the OC scanner created for me, here it is. You can see the new curve is in bright white versus a darker gray as the default one. It made some decent automatic boost, and we can still flatten it if needed. Finally, in case you don't plan to use Afterburner for overclocking but want to use it just for monitoring like in OSD, make sure you go to its settings and disable hardware control and low-level I/O. This prevents it from overriding your GCC overclocking profile, so they don't interfere with each other. Back to GCC, one nice thing here is that you can export and import performance profiles. I've included a link to download mine in the video description and pinned comment. The reason I included this profile because dialing the memory speed manually in GCC is super tedious. It doesn't let you dial in a number here, so you'd have to keep clicking the plus button dozens of times to reach 6000. So to not waste your time, I just included this profile so you can import it directly. Alright, with our OC settings set, let's talk about stability and benchmarks. In Furmark, we are seeing a steady 2835 MHz core clock and 2125 MHz memory clock. It's rock solid and stable for me with the same power draw as before. I've left it running for over an hour with no crashes or dips. So it's super stable this way. I also ran 3D Mark Port Royal stress test with its 20 loops, and it passed well, no issues whatsoever. On average, we gained around 7 FPS in that test. In addition to that, I ran a bunch of other 3D Mark tests as well. In Timespy, we saw a small uplift of about 800 points on the GPU score, not a world record, but a nice pump. But wait until we get to Timespy Extreme, where the gains were bigger, over 1200 points in graphics, with a total score reaching 24,312, which is quite excellent according to 3D Mark. In Port Royal, we gained extra 5 FPS on average, which translates to 1,300 points increase. In Steel Nomad, we again saw a 5 FPS bump and a 500 point gain. Finally, in Speedway, the uplift was 6 FPS and about 600 points increase. So across those heavy tests, we averaged about 5% uplift overall, which is solid considering how easy the overclocking process was. Now is the time for some actual game performance check. In Cyberpunk 2077 at 4K, low settings, without DLSS, frame gen, or ray tracing, you can see that our core clock is over 3000 MHz and we gained around 15 FPS on average. But when we cranked everything to native 4K, high RT settings, no DLSS or frame generation, only gained about 1 FPS. Instead, in Black Mesa Wukong at 4K native resolution, low settings, no DLSS, frame generation or RT, we can see that our core clock has improved as well. Just like in Cyberpunk, it's over 3000 MHz. And we saw also a 7 FPS increase. While at 4K, high RT without DLSS or frame generation, we got 2 FPS uplift. So that's not the normal use case of this GPU. You're going to use some upscaling, frame generations, stuff like this. So guys, that was it for this video. Thanks to this overclock, we gained around 5 to 6% performance uplift from originally already high factory clock with just some simple changes. And it's super stable. Of course, many users might be also interested in undervolting to reduce temps while keeping most of the performance there. But in this video, I wanted to focus mainly on maximizing the performance as much as possible. Still, it's not a crazy world record-breaking overclock, just a daily driving, reliable OC. So thanks for watching. If you liked this video, please give it a thumbs up and subscribe to the channel, and let me know in the comments below if you have tuned your GPU and what kind of gains you've got, even if you are using a totally different model than this one. Thanks again, and see you in the next one.